Okay, in this next video in the MST-80 series, I think it's time to put the electronics back in the briefcase. So let's do that next. So let me get this moved out of the way someplace where we can get at it, but it's out of the way. See if we can figure out how to do this and not jostle things around so much that it causes shaky video. So I'm going to have to make an adjustment on the camera stand here, which I'm sure just created a bunch of shaky video. I apologize for that. This is actually pretty dirty inside. I think I want to clean that out a bit. Yeah, I'm using breath to blow it out. Huh. There's a piece of masking tape inside that I don't really know what it means. Oops, I just knocked a drill over. Never have enough room. Never, ever, ever have enough room. So, we can start by just sitting the main board in place. There are a number of flathead screws here that hold it in place if I can get a hold of one of them. Doesn't need to be super tight. I just want it to be enough to kind of hold it in place. Oh, I hate flathead screws. They are just not fun to deal with. As I said, they are not fun to deal with. Lift the power supply is unplugged. I won't shock myself here. We can lift the module into place and hopefully feed this wire bundle up under someplace. As we attempt to drop that down in place, that's where it goes. We've got 4 nuts. Those back ones are going to be just a laugh a minute to start. Looking at the witness marks now, I can see where that power supply has been removed previously and put in. Wow, that is a difficult place to get into. Of course, I remember these being difficult to get out, so gets the basics hooked together. I've got to get nuts down into there and started. And there's actually a way that sometimes works well for this. I've got the nut on the awl, I'm holding it in place. I kind of get the sharp pick down on the screw head. And we see if we can get the nut to catch. This box really working. There it went. So if you're ever desperate in a tight spot like that, that might be a strategy that'll help you. Now I'm just trying to spin the nut down. I didn't clean all of that dead silicone off like I said I was going to. I'm not sure why there was silicone. Beyond there just was. Long needle nose pliers here, which I think will be sufficient. I don't know if I'm actually on camera here or not. Is that what's going on? Yeah, Trying to keep my head out of the way. I have no idea if I'm actually on camera here or not. If I'm not, I've got a pair of very long needle nose pliers that I'm using to get about 1/8 of a turn at a time on this nut. Okay, I felt that torque up. We'll do the same thing here. Got the line cord in the way, which makes it even more difficult. Why can't I keep a grip on these? I've been able to on the other 3 nuts. There we go. I'm happy with that. Sorry if I'm making the camera shake here. I probably am. The screws in this are not all identical, but they're the ones that were in it. The screwdriver's slightly magnetized, so hopefully I can do that right there. Apologies for the washing machine noise in the background. Laundry has to happen, fact of life. And the one screw that's really different from all the others that's longer is this guy. I'll just put it in the center here. There was this washer. It is a locking washer for a switch. It was probably on that switch. Maybe it was meant for it at one point. I don't know. That was loose as I remember. Inside of here, I'm not going to put a loose washer back in. You need to be tight enough to stay tight. Oh, excuse me, but not so tight as to cause issues. I'm a little bit. I'm sitting on the cord. That's why it's so. Oh, come on. Oh, good Lord. I want to stand this up. I think this screw right here underneath is a little bit loose, perhaps. Yeah, it is. I say that because I could feel the shaft, the shaft and side spin. You know, the whatever you want to call it, the standoff. These have got like double. I don't think I loosened these myself. They're all a little bit loose. So that's all back together. Briefcase is opened. Power is, I believe, off in that position. Plugged in. Power on. It reset. Octal 002. For the load high 000, the entry point in this ROM for the DAISY program. And there's the data that it's spitting out, that if we had a radio someplace in the area, we would hear it making the DAISY song. There it is. I've got a couple things to put back into it. There is a nice scanned, cleaned up, and printed out copy of the manual. I've got some other stuff that'll go up here as well. I've got the original capacitors that came out of it that I will be keeping with it just because they're original parts of it. Bad 8224 that came out of it. We've got that 7474 that was bad. And because it was bad, actually allowed the system to work, as strange as that sounds. So I'm going to go ahead and hold on to those because they're original parts. There's the original parts we pulled out, just so they live with it. I added this HP display over here, this third one. It didn't exist. It was hex mode only, and I added that one. If we reset it, change it back to hex, well, reset takes it back to hex. 02, load high, 00, run. We'll just see the hex values of what it was displaying in Octal before. Is there anything else to talk about here? We can enable single step. We can single step. Back to run, and it picks up and runs again. Because of the number of the inner and outer loop, this could be a lot of clicks while it's in that delay loop. Is there anything else we can display here? I did notice deep down in there, if I can get it out, this piece of copper wire. We should maybe be able to do something interesting with this, actually. Let's look up the pinout while we're here for the connectors. They're in the nice cleaned up manual here. We have A0 sitting in this block down in that bit. Let's go ahead and tie him to an LED. The LEDs are hooked up to this side over here. So that's light 1. And if we take that up to address 0, we see the LED got dim there. So you can see the LED now flashing as I single step. That's address 0. So that, it's kind of proof there that we are single stepping. If I go back to run, the LED will be on but dim. We can go to address bus 1 here. And it'll take a little more clicking now to get it to 4 clicks, 2 clicks. It'll take a little more clicking to get it to do anything. I think this pretty much completes the series. We may do some experiments with it going forward, but that'll be, I think, outside of this series of videos. You got through all the videos and you're here at the end. I appreciate it. Thank you. Guess I can spend a minute here and recap. We did this in the last video, but I'll recap here everything we had to do. The 5.1 volt Zener diode down here was bad, causing the minus 5 volt rail to be at like minus 2 volts, I think. Zener was replaced. A bunch of these original caps, so the blue ones over here, were way off, so they weren't 5 microfarads. They were, really, really low, or they're really, really low, very leaky. Replaced them all with 47 microfarad, their power supply. All of these down here are just power supply filters. So 47, 5 microfarad. It's what I had in stock. This one up here is for the power on reset. When the system's first powered on, the capacitor is discharged. There's a resistor here next to it. It's an RC time constant. As the capacitor charges, eventually it moves from a 0 to a 1, and the system starts up. It creates that delay for the power supplies to settle. 47 microfarad just means it's taking longer to get out of reset than it would with the 5 microfarad, one of these in there. Not a huge deal. There was a jumper on the back of this switch that I think was an attempt to make the system run no matter what. It's been removed. The 8224 clock rate generator here was bad, so this is a 2-phase clock generator. It uses the crystal. There's a couple of capacitors here on the crystal to produce a 2-phase clock that drives the 8080. And there's a 2-phase, phase 0 and phase 1, or phase 1 and phase 2. I don't remember how they're labeled. I think phase 1 and phase 2 actually. Clocks that come to the 8080, and I believe those actually swing more than ground and 5 volts. I think that they drive harder than that. There's a phase 2 TTL output on here that is just a TTL equivalent of that phase 2 signal. That on the original 8224 over here was bad. It was just stuck low. It was actually shorted to ground, if I remember right. So that phase 2 TTL coming out is part of the single step circuit, and it allows the system to see the single step happen and then latch and stop at the next cycle. And without that clock happening, the circuit down here couldn't reset. There was a 7474 in this socket location. The schematic called for a 7479. They're both, I believe, D flip-flops. There's a kind of difference in them that I don't fully understand yet. I got to study the data sheets. But we've put the correct part back in. The 7474 that was in here had the Q and Q0 outputs open, essentially, on one of the flip-flops. And the fact that those were open allowed the ready signal to basically drift high and the system to run. Yeah, allowed ready to actually be, ready to be driven high and the system would run. How that happened, I don't really know. I'm imagining the 8224 TTL output phase 2 went bad and somebody mucked around down here and didn't realize that was the issue. This is the first time I've ever seen a 7479. I had nothing in my stock. I had to special order these, well, not special order. Unicorn Electronics had these in stock. I bought a couple 8224, so I've got a spare. A bunch of the TI logic. There's an example here, you probably can't see it. Excuse me, the pins are highly corroded. So it's not unusual on this old TI stuff to see the pins, they're silver plated and that silver turned black. I used a bristle brush. I think it was it was a steel bristle brush, I believe, and I brushed the leads to knock as much of that black off as I could, just to clean them up, and then resocketed them, and the system runs, so they should be fine. I've tried Brasso and other things to clean these pins. I've never had any luck with them. The 3 EPROMs here, the 1702As, had a different program in them. I don't know what that program was. I captured it. I needed to disassemble it, see if I could figure it out. These were erased, and you saw us basically wire a 1702 EPROM programmer up to RC 2014 and write some custom software to be able to program these with the monitor from 1979. We also, as part of this whole project, captured the source for that monitor and got it to build using TASM64. And that's the Telmark assembler, not the turbo assembler. The Telmark assembler, 64-bit version under Windows 10. So I was able to recreate the monitor and actually assemble it and get a bit identical hex file out of it that we then programmed into these. We then took the DAISY program we found on a programming sheet and its data and manually entered that and got it to assemble and programmed it into this device here. What else have we done here? This part was in the board when we got it. It's a 1488, so it's either a serial receiver or line driver, an RS-232 driver or receiver, I don't remember which, the 1488, 1489, or a pair, to create RS-232 drivers and receivers for the full IEEE, plus 12 to minus 12 essentially levels. That kind of is a clue that somebody may have been trying to do some serial stuff on here at some point, although I don't know that. Anything else to talk to? These blue sockets were a little confusing at first. I couldn't figure out how to release the part. They are zero insertion force or ZIF sockets. In the previous video, you may have seen me release one. The best way I know to release them is to actually capture under the lid of the top of the socket on the two ends. I'm not connected to the EPROM. I'm actually connected to the top of the socket here is what I'm pulling on. And the top of the socket will lift up, maybe, and latch up. If I can get it to go, there it went. So the top of the socket is raised about 1/8 of an inch, and that releases the pins on the 1702 here, which I can't seem to lift out. There it goes. That releases the pins, and then you drop the part back down into the socket, get it flush, and then you push down to snap it in. So they are zero insertion force sockets. You saw me struggle before I figured these out. The 40 pin one here is a bear to get to release. It's nice to know how these sockets worked. I've seen them, I think, maybe in the past or something similar. And it was just nice to figure out that you pull up on the top of the socket itself, and that's why there's these overhang, these lips on the top and bottom. 02, load high, 00, run, and there's the DAISY program running again. Anything else to discuss here? I keep saying it, we keep coming back to it. I think we've recapped well. Well, thank you again if you're still watching. I've said goodbye several times. Appreciate it. Like if you think it's worth it. Subscribe if you think I'm worth it. If not, no big deal. Any feedback you want to give me will get read. Any comments will get read. Anyhow, let's finally finish this one up, and I'll see you in a future video.